Okay, I had to cut that video short, so it's just continuing here. So we have it set up, and let's see here. So 4.5 times 10 to the 2 multiplied by negative 58. I believe that gives us negative 26,100. Oops. Plus, so then multiply all that. Well, that's all going to be equal to 0. So let's see, it's 836. So to get this term by itself, then I'm going to have to, first of all, isolate the term, which means subtracting 836 from each side. Then divided by negative 26,100. Notice you're going to have a negative divided by negative, so that makes sense. We're going to get a positive answer. So we get 0.03203 kgs. I can put that in scientific notation. I think I rounded it off to 3 sig figs here. So place the decimal here after the 3. That means it's 2 places to the left. It's 3.20 times 10 to the minus 2 kgs. All right, so you can jump ahead and try the next one. I'll continue with it here in a moment. Okay, so I look at the next one. Silver is heated up to 90 degrees, and then it's placed in ethyl alcohol, but it has an initial temperature of 5. Determine the final temperature of that. So I'm given mass, so I don't have to worry about a density conversion here. So silver, and then we're putting it into alcohol. So it doesn't have to necessarily be in water. So silver is a metal. I'll just simply call that metal. Maybe I'll call this, I don't know, L for liquid. Metal and liquid. So 200 G's of silver. Again, you can call it whatever you want here. So change that to kgs first of all. The alcohol was 300 G's. So of course that's that. Let's see here, specific heat capacity of silver. So if I look up silver, 2.4 times 10 to the 2. 2.4 times 10 to the 2 joules per kilogram degrees C. And the initial temperature of alcohol was 90. Final temperature of alcohol, when all is said and done, oh, we're asked to find it. We don't know what it is. All right, so over here I'm going to have here, so T final will be equal to TF minus TI. So the best I'll be able to do here is just simply say TF minus 90. That's the only thing I can do there. The alcohol, specific heat capacity of the liquid here, specific heat capacity of the alcohol, 2.46 times 10 to the 3. And the initial temperature of alcohol was 5. And again, the common final temperature is what I am looking for in this question. So it's a little bit different, a little bit more equation manipulation, but it's definitely doable. So you can see here we're going to be solving for TF. Okay, so Q silver plus Q, I don't know, call it ethyl, doesn't matter. So the M of the metal, the C of the metal, the delta T of the metal, then the Q of the liquid, or sorry, this should be an M. So use a little magic to fix that up. Liquid, C liquid, delta. And again, I use liquid. I could have used an E for ethyl, it doesn't matter, or an A for alcohol, whatever works. 0.2000, 2.4 times 10 to the 2. And then here, now I'm going to use this version here. So TF minus 90. TF minus 90. Then over here, 0.3000, 2.46 times 10 to the 3. And I'm running out of room here, so I'm just going to write it here. TF minus 5, all equals 0. So to simplify this, I can likely multiply that first and multiply that. Okay, so I'll multiply these two terms. 0.2 multiplied by 2.4 times 10 to the 2, that's going to give me 48. Multiplied by TF minus 90. And then over here, 0.3 times 2.46 times 10 to the 3, that's going to give me 738.0. So simplifying a little bit more. Now, of course, the next thing you do here, so we have a monomial and a binomial. So yes, distribute the monomial over the binomial. So 48 times TF is 48 TF. 48 multiplied by negative 90 is negative 4320. 738 multiplied by TF is going to give me this. Then 738 multiplied by a negative 5. Oops. Jumped ahead there, so I'm going to have to back up here with some magic. 738 multiplied by negative 5 is negative 3690. All right, so I have some common terms here. I have a TF terms that I can combine together. And I have two terms that don't have a variable. So 48 and 738 gives me 786. And then negative 4320 and a negative 3690 gives me negative 8010. Okay, so again, so you can see it's a little more manipulation here, distributing, but you can definitely do it. So to get this term by itself, I'm going to have to move the 8010. So 786 multiplied by TF is equal to 8010. Then divided by 786. And TF 10.19 degrees C. I think I rounded it off to, let's see here, 2 sig figs. 10 degrees C. All right. Now the one on the next page is very similar to this, so I recommend stopping the video and looking at it. I'll come back in the next video and do the next 2 examples, hopefully. But in the meantime, give it a try. It's involving solving for TF again, very similar to this one. We'll see you again.